Welcome back everyone to the Hello World guide. This is another episode of the OpenGL 3D renderer series, and in this video we are going to continue by creating a structure or a class called mesh to store our shapes here instead of doing that manually with creating different VAs, because that will get a bit repetitive. So what we'll do is we'll create a separate class and that will handle all of the stuff for us. So yeah, let us get started doing that. So in order to do that, I'm going to go under Solution Explorer and add a new class here, add a class, and I'm going to call this class mesh and hit OK, and Visual Studio will generate the files for us. So now let us start to populate this mesh, and we are going to have a couple of public methods and some private ones as well. So for here, what we are going to do is we are going to include vector here. Now in the original thing that we did in the main function, we use C-style arrays, but for this we will use vectors. Now you might be tempted to just say something like a vector std : vector of floats called vertices, but our each vertex needs to have an x, y and z value, and we should probably, you might say we are going to create a class like vector, so we can create like a class here called vector, but we are not going to do that. Instead we are going to use a math library called glm, which stands for GL math library, and I have installed it using VC package. It's mostly a header only library. You can download it as well, but I have installed it using VC package, which means it's going to take care of the dependencies for us. And now our vertices are going to be a vector of glm : vec3, which means it's basically going to be a vector. And when I say this vector, it might be a bit of confusion, but a standard vector, std vector, is going to be one thing that stores a bunch of data, while this vector refers to an xyz value, the glm vector. So I'll refer to that as vec3 and the std vector as just vector. So we've got a vector of vec3s and another vector of unsigned integer called indices, and we also create three unsigned integers, a VAO, VBO and EBO here. Now for actually public here, we are going to create a mesh called mesh here, which is going to this means you are creating a constructor which is going to basically take the same vertices. So you're going to create a we are going to take in a vector of vec3s called vertices and another vector of unsigned integers called indices. And yeah, that is pretty much it. So we are going to implement this construction in a CPP file, and remember that our mesh class is going to be only writable once. So when we create the mesh, it's going to create the VOs, VBOs, everything, but it won't allow us to actually change the data later. And for most applications, you don't need to change the mesh data. So you might say, want to cut this, or let's not cut this, let's just copy this and let's go under mesh.cpp and paste this here. Now it of course gives some errors on GL generate buffers and stuff, because we are not including GL slash GL, that actually not GL.h, we need to include glue.h. And yeah, now it works, and it gives us a warning about things not being initialized. So we are going to initialize vertices, indices and EBO, VBO, everything. So yeah, for vertices we'll just initialize it with the actual argument that we have got, and it will automatically detect that even if they've got the same name. And then the actual VBO, EBO and VAO, we'll just initialize them using the default values, calling the default constructor, which will put them to basically the 0 value. So you can see it is giving us an error about vertices, because vertices is not a C-style array, we can't actually use it directly, and the size of vertices won't work too, because we need to provide the actual complete size of array, including each in bytes. For the actual pointer we can just say vertices.data, and for the actual size what we can do is we can say size of for example we can say glm : vec3, size of that. But what we will have to do is we'll just say vertices dot we'll just say vertices dot size multiplied by that, which means it will give us the size in bytes, not in how many elements the array has, but the actual size in bytes. Since it does not know the type, we can't actually have it do like that. We'll have to give it the complete size of the array for buffers, because a buffer is just an arbitrary piece of space. And for the indices we do a similar thing, but this time we actually use the uint32 here instead of that, and we'll say indices.data as well, since we of course want to take the C-style array from there. So we'll say indices.data, which will give us the actual data. So yeah, that works, and let me just increase the font size a bit so you can see a bit better. And yeah, so you can see that we have pretty much got everything settled here, and now we need to figure out how to draw this mesh. We have got the initialization phase completely done. So for this we will create a function called draw, which will take no arguments, and it will be marked const, because it's because we are not going to modify the mesh, so we should mark it as const. And what we'll do in here is we have got the draw function, but we are basically going to go under our 3D renderer .cpp, the main file, and we are going to copy basically this thing that we do for setting the, for actually drawing. We'll just copy this and go under mesh.cpp and paste that, and but the only thing we are going to change here is when we are calling draw elements, we'll call indices.size here instead of just 6, so that we can have a variable amount of things here. So that's pretty awesome, and now we can delete all of this code from here, and we can go ahead and basically create a mesh and put our vertices and indices in there. So you can see I have put my vertices and indices directly here as initializer lists, and we can remove this now, and notice that I am now not using plain floats but instead initializing vector 3s of GLM, and we are going to call mesh.draw here, and make sure you have got the mesh header included, of course. And what you should see is that now everything works in the same way it did before, and we do get a scare onto our screen. So let's go ahead and test that, and what you should see is that the mesh is able to generate everything in the correct manner. So yeah, let's just wait for a while for it to actually compile, and you can see that it has compiled successfully, and now the program runs. What we see is that we do get our same yellow scare onto the screen. So that is pretty awesome, and now what we can do is we can go ahead and for example, if we go ahead and call GL polygon fill, not GLM, GL polygon fill, and polygon mod actually, not polygon fill, and we are going to say GL front and back for the face, just like we did in the previous video to render it in wireframe, and for the mod we'll just say GL underscore line, so it does not fill and just draws the line. So if I run that, you should be able to see the two triangles separated. So yeah, this is pretty much it for this video. I'll see you in the next one, which will make more stuff like maybe a class for shaders and add 3D transformations and stuff like that. So stay tuned for that, and I'll see you in the next one. Make sure to like and subscribe as well, and bye.